Alright, let's go. Here's a very detailed, engaging, and visually dynamic and fascinating topic we have. Science of Wormholes, exploring the tunnels through space and time. 1. Introduction. Hello dear, curious minds. Welcome back to CHIZHIM Science Tech YouTube channel. Here to give you the very best you can ever imagine, and this is where we explore the mind-blowing wonders of the universe and the frontiers of science. Today, we're diving deep, really deep, into one of the most thrilling and mysterious concepts in modern physics: wormholes. Are wormholes shortcuts through space and time? Are they real? Could we ever travel through one and emerge light years away, or even in another universe? Buckle up, because what you're about to discover might just bend your mind like space-time itself. Let's open the cosmic gates and begin our journey through the science of wormholes. But before we start, do the following. Click the subscribe or bell icon, like, share and comment after watching. 2. What is a wormhole? Wormholes, also known as Einstein-Rosen bridges, are hypothetical passages through space-time that could connect two distant parts of the universe, or even different universes entirely. Imagine the universe as a sheet of paper. If you draw two dots far apart and then fold the paper so the dots touch, the wormhole is the tunnel that connects them. Instead of traveling the long way between those points, you jump through the tunnel in an instant. Wormholes are rooted in the mathematics of Einstein's general theory of relativity. They're not science fiction fantasies, they are real, mathematical possibilities. But that doesn't mean they actually exist. Not yet. Chapter 3. The Origins, Einstein and Rosen. In 1935, Albert Einstein and his colleague Nathan Rosen explored the idea of bridges in spacetime while studying black holes. Their work led to the formulation of the Einstein-Rosen bridge, which mathematically described a tunnel linking two black holes. However, their model had a big problem. The bridge would collapse too quickly for anything to pass through it. This led to a new question: could wormholes exist in a stable form? Could they be kept open long enough for something, or someone, to travel through? 4. Traversable wormholes, science meets sci-fi. In the late 1980s, physicists Kip Thorne and Michael Morris proposed the idea of traversable wormholes that could be stable enough for travel. To do this, you'd need exotic matter, a form of matter with negative energy density and negative pressure. This exotic matter could counteract the gravitational forces that would normally cause the wormhole to collapse. Now, this doesn't mean we've found this exotic matter, only that our equations say it might be needed to make wormholes work. The idea of traversable wormholes helped bridge science and science fiction, inspiring books, films, and wild theories. Chapter 5. Black holes and wormholes, cousins of cosmic extremes. Black holes and wormholes are often confused, and for good reason. Both are extreme distortions of spacetime, and both are solutions to Einstein's equations. But here's the key difference. A black hole is a region of space where gravity is so strong that nothing, not even light, can escape. A wormhole, on the other hand, is a theoretical tunnel that connects distant regions of spacetime. Some theories suggest that the center of a black hole could be a wormhole. But current models show that trying to travel into a black hole would crush any traveler due to spaghettification, a delightful word for a terrible fate. Chapter 6. Time travel through wormholes. Could wormholes allow for time travel? The short answer, maybe. According to Einstein's relativity, time and space are interconnected. If you move one end of a wormhole at near light speed and bring it back, the two ends could become time-shifted. This means that stepping into one end might take you to a different point in time, not just space. This concept fuels many time travel theories, but it also leads to paradoxes. What happens if you go back and prevent your own existence? The infamous grandfather paradox remains a thorn in the side of time travel logic. Chapter 7. The Big If. Do wormholes really exist? As of today, wormholes have never been observed. They remain purely theoretical. There is no experimental or observational evidence that confirms their existence. But some theories suggest that if wormholes exist, they could be hiding in plain sight, perhaps at the centers of galaxies, or as relics of the early universe. Scientists are also studying gravitational waves and high-energy cosmic events to search for signs of wormhole behavior, such as anomalous lensing or duplicate signals. Chapter 8. Wormholes and quantum physics, the ER equals EPR conjecture. Here's where things get really wild. In recent years, the ER equals EPR conjecture, proposed by physicists Leonard Susskind and Juan Maldacena, suggests a deep connection between wormholes, ER, and quantum entanglement, EPR. This theory proposes that entangled particles may be connected by tiny wormholes. If true, this could mean that the fabric of reality itself is laced with microscopic space-time tunnels. This would be a unification of general relativity and quantum mechanics, a holy grail in physics. Chapter 9. Building a wormhole? Could we ever do it? Let's entertain the impossible. Could we ever build a wormhole? Theoretically, you'd need control over immense gravitational and quantum fields, exotic matter with negative energy, the ability to stabilize spacetime under extreme conditions. This would require technology far beyond our current capabilities, perhaps even a Type 3 civilization on the Kardashev scale. Still, thinking about how to build a wormhole pushes our engineering imagination and helps us understand the limits and possibilities of physics. Chapter 10. Wormholes in pop culture. From books and movies to video games and comics, wormholes have become a symbol of interdimensional travel, infinite possibilities, and the strange beauty of theoretical physics. In Interstellar, Kip Thorne helped craft a scientifically plausible wormhole that made the film's visuals unforgettable. In Stargate, wormholes became portals to other worlds. In Rick and Morty, they're the foundation of absurd and hilarious chaos. Pop culture uses wormholes as a metaphor for exploration, escape, and evolution. Chapter 11. The limits and risks of wormhole travel. Let's imagine we found or built a wormhole. What could go wrong? Instability. Without exotic matter, wormholes would collapse instantly. Radiation. High levels of radiation could be trapped inside. Tidal forces. Like in black holes, intense gravity gradients could tear things apart. Causality violations. Time travel creates paradoxes that might destabilize the universe, or at least our understanding of it. Any journey through a wormhole would be immensely dangerous, even in the best-case scenario. Chapter 12. Conclusion. The future of wormhole research. Wormholes challenge our deepest understanding of reality. They represent what's possible at the very edge of science. And while they may remain in the realm of theory for now, their study has already changed the way we think about space, time, and the universe itself. Perhaps in the distant future, humans, or some advanced intelligence, will harness these cosmic shortcuts to explore the stars, transcend time, or unlock the secrets of the multiverse. Until then, wormholes remain the ultimate scientific mystery, a bridge between imagination and mathematics, physics, and dreams. Thanks for joining us on this epic journey through the science of wormholes. This is CHIZHIM Science Tech channel, where you're valued and appreciated for watching. If this blew your mind even a little, hit that like button, share this video with your fellow space lovers, and subscribe for more deep dives into the cosmos. Got a theory, question, or thought? Drop it in the comments. We love hearing from you. Until next time, stay curious, stay cosmic.